Subnetting with variable length subnet masks, example number 1. A company uses address range 10.0.0.0/8 and they want to create smaller subnets, and these are their requirements. They want two 500 hosts subnets, one subnet with 220 hosts, four 50 hosts subnets, 3 subnets with 10 hosts per subnet, and then finally 2 point-to-point subnets. We're going to start off with a table, and first we're going to fill in the number of hosts required for each subnet. We're going to sort those subnets from the largest one to the smallest one. And a small disclaimer here. In each of these subnets, we're actually going to need 2 more IP addresses than is stated here. So for example, in the requirement, we're told that the first subnet is going to have 500 hosts. So we need 500 IP addresses, but then we need 2 additional IP addresses, one for network ID and one for broadcast IP address. We're going to consider this in our next example, but for now, we're going to use the exact number of hosts as the number of IP addresses that we need for each subnet, except of course for the last 2 networks, because it's really obvious that we need at least 4 IP addresses in a point-to-point network. Okay, so the first subnet is going to have a 10.0.0.0 network ID, because that's what we got in the requirement, and so that's what we're starting with. This is what 10.0.0.0 looks like in the binary format, and I've underlined the first octet because that is our default network portion. We're going to use 9 bits for our host portion because that gives us 512 different combinations. If we used 8 bits, 2 to the power of 8 is 256, and that's not enough for our requirement for our first subnet. So we're going to go with 9 bits. That means our new mask is /23. 23 plus 9 equals 32, which is a total number of bits in an IPv4 address. That's how we got that number. Now let's think about the broadcast IP address. To determine the broadcast address, we need to switch all of the bits from our host portion into ones. So when we do that, we have 9 ones at the end of our IP address. So the broadcast IP is going to be 10.0. Those are the 2 first octets, and they haven't changed. But the 3rd octet has changed, and that's going to be 1. And then the 4th octet is going to be 255. So the broadcast IP is 10.0.1.255. Now the range is the easiest one to determine because we're just going to go from the first address after the network ID and then up to the one address before the broadcast IP address. So we're going to go from 10.0.0.1 to 10.0.1.254. Our next subnet's network ID is just going to be the next address after the broadcast IP from the first subnet, which is 10.0.2.0. And this is what it looks like in binary format. Now we're going to use /23 mask here too, because we also need 500 hosts for this subnet. And then for the broadcast IP, we're going to switch the host bits to ones, which means that the 3rd octet is now going to be 3, and the 4th octet is going to be 255. So the broadcast IP is 10.0.3.255. Range of usable addresses goes from 10.0.2.1 to 10.0.3.254. Network ID for the 3rd subnet is obviously going to be 10.0.4.0, and this is what that looks like in binary format. This time we're going to use 8 bits for the host portion because 2 to the power of 8 is 256, and that's enough to fit the 220 hosts from our requirement. 32 minus 8 is 24, so that's our new mask, /24. And we're going to switch the 8 host bits into ones in order to get our broadcast IP address. So since the first 3 octets haven't changed, that's going to be 10.0.4.255. Range is easy. It's going to go from 10.041 to 10.04254. And then our fourth subnet network ID is going to be 10.050, which is the next address right after the broadcast IP of our third subnet. Let's see what that looks like in binary format. So this is 10.050 in binary format. This time we're going to use 6 bits for our host portion because 2 to the power of 6 is 64. So we can fit the 50 hosts into that. So that's good enough for us. If we use 6 bits for hosts, that means our new mask is going to be /26. So we have 26 network bits and 6 host bits. To get a broadcast IP, we're going to switch all of the host bits into ones. And now the value of this fourth octet is going to be 63. So our broadcast is 10.0.5.63. Range is as always easy. It goes from 10.0.5.1 to 10.0.5.62 in this example. Next subnet network ID is 10.0.5.64, and this is what that looks like in binary format. The mask obviously remains the same, and then to get the broadcast IP, instead of 6 consecutive ones, now we have 7 consecutive ones. So these 6 consecutive ones added up to 63, and then 63 plus 64, which is the value of this bit, equals 127. So that's our broadcast IP, 10.0.5.127. Range is again easy. It goes from 10.0.5.65 to 10.0.5.126. Again, our next subnet network ID is going to be the address that comes right after the broadcast IP from our previous subnet, which is in this case 10.0.5.128, and this is what that looks like in binary format. Mask, of course, remains the same, /26, and then for the broadcast IP, we're going to switch all the host bits into ones. These 6 ones add up to 63, and this first one is 128. So 128 plus 63 equals 191. So our broadcast IP is 10.0.5.191. Range of usable IP addresses go from 10.0.5.129 to 10.0.5.190. And then one more of these 50 hosts networks. Network ID is going to be 10.0.5.192. Mask remains the same, /26. And this is what this looks like in binary format. Broadcast IP is this time easy to calculate, is going to be 10.0.5.255 because we've finally filled up the fourth octet with ones. Usable IP addresses range from 10.0.5.193 to 10.0.5.254. Next subnet network ID is 10.0.60. Let's see what that looks like in binary format. So right now we have 5. In order to get 6, we're going to switch these 2 bits. Now we need to determine the mask. We're going to use 4 bits because 2 to the power of 4 is 16, and we only need 10 addresses, so 16 will do. This means that our new mask is /28. Now, I want to stop for a minute here and explain something further. Up until now, we've used this CIDR format for our masks, but you should know that you can't always use this format. For example, when you're configuring a router, you can't just say, here's your IP address, for example, 10.0.6.5, and then say /28 or 26 or whatever. You can't. You have to write a mask in a decimal format. So for /28, you have 28 ones and then 4 zeros. This is how masks work. In decimal format, that's 255 in the first 3 octets, and then in the last octet, we have 240. So that's what you would type in to a router if you're using a /28 mask. All right, let's move on. So to determine the broadcast IP, we need to switch the last 4 bits into ones. That's going to be 15. So the broadcast is 10.0.6.15, and the range goes from 1 to 14. Network ID of the next subnet is going to be 10.0.6.16, and this is what that's going to be in binary format. Broadcast for this subnet is going to be 31, so 10.0.6.31. Range goes from 17 to 30, and then the network ID for our next subnet is going to be 10.0.6.32. Mask stays the same, /28, and this is what that looks like in binary format. Now, broadcast is going to be 32 plus 15, which is 47. So it's 10.0.6.47, and then range goes from 32 to 46. Again, a network ID for our next subnet is just the next IP address, and in this case, that's 10.0.6.48. And this is what that looks like in binary format. The mask, of course, is going to be /30, as we've discussed earlier. And then broadcast is going to be 48 plus 3, which is 51. So that's 10.0.6.51. As for the range, we can anyway only use 2 IP addresses, and these are 49 and 50. Finally, our last subnet network ID is 10.0.6.52, and this is what that looks like in binary format. The mask, of course, remains the same, /30. For the broadcast IP, we need to switch these last 2 bits into ones. When we do that, we get 55, so our broadcast IP is 10.0.6.55. As for the range of usable IP addresses, again, we can only use 2, and in this case, those 2 are 10.0.6.53 and 10.0.6.54.